Once again,
We're
Universe
live.
Today, ahead of all the things. We report on the news 3 months in advance, and then our hands are tied when everybody else catches up. It's like so passive aggressive. I don't I never realized this would be the problem, that I would get so good at finding news that I would be able to get a 3-month jump on everybody else
And
who's
part of it
reporting the
is
news.
so many of us just wait until the peer-reviewed paper comes out.
No,
And
everybody waits until the press release comes out. Nobody's waiting for the peer review paper. Everybody's waiting for the
I
press release.
wait for the
Nobody notices
peer-reviewed
stuff.
paper.
Well, you wouldn't. Are you going through archive every day, seeing interesting papers, and saying, "Ooh, I'm going to wait for the peer review paper to come out"?
No, I'm doing
Is
that
that
once a week.
sure? Wait a minute. There's 70 stories a day on archives. You're going
Okay.
through
I usually
500 papers a week on archive.
No,
You're
I
just
don't
looking
go
through the
through all
journals.
of them.
You're just looking through the journals, right?
So I will usually search on keywords for things that I'm trying to follow.
Yeah.
So yeah, I'm not reading all
Yeah.
of them. No, I really
Yeah.
do not care about string theory, it turns out.
Well, it's
And
easy to do to ignore all that. Yeah, no, you can ignore all of that nonsense, but there's lots of such great stories and a lot of great summary stuff.
yeah,
Like here's the state of the business so far.
yeah.
There's a paper that came out on Friday, which we're totally going to cover, and it is like the most boring thing ever. JWST, the crazy galaxies JWST has found fit nicely into the Lambda CDM model and are perfectly explained by existing theories.
Yes, I saw that one.
JWST has failed to disprove the Big
Yeah,
Bang.
yeah. I love this. Yeah,
I
that's one
love
of
it too.
it's
Yeah.
it's one of the things I'm going to cover with EVSN this week. So
Okay.
yeah, that
Yeah.
one I totally
Okay,
that's
all right.
on the list of things I've been following.
Okay, yeah, we're going to cover that as well, and I'm going to make a big deal about it because it's just like it's so funny. You have all these people like, oh, JWST disproved the Big Bang. Nope,
No.
it didn't. And not only that, it failed to disprove it.
I deeply appreciate that both the standard model of particle physics and lambda cold dark matter standard model of cosmology keep being threatened and then going, no, we are here to stay.
Yep.
It is pleasing.
John Seffel asks, how long is a piece of string theory? It's as long as it needs to be.
And it's a tangled mess that cats have been playing with. And I look like a vampire the way we're lit today, the way I'm lit today.
Yeah.
I'm just going to go with it. I think that may
Yeah.
actually be my actual color.
Yeah. Yeah. Seeing us side by side.
Yeah.
What else is going on? Oh, yeah. So we put some artificial intelligence to production on the Universe Today servers. We're actually using
what?
We put some AI, some Chat GPT
Okay.
into production. So I am now using Chat GPT to modify stuff on the Universe Today system. You ready to hear what we're doing?
Yeah, go for it.
Okay, so when we publish a new video, I write this blurb, and then we have a bunch of boilerplate, and the number of paragraphs in the blurb and where the boilerplate begins changes every time. And so we wrote a filter that uses ChatGPT that only extracts the intro blurb and removes all the boilerplate and puts it into a new field in our database.
Okay.
Extreme, I know. And then the other thing that we've got is that I will write a title for a story that I send out to the writers and I put it into our database.
Yeah.
They will realize that I made mistakes with my title and they'll fix the title. So they'll fix the punctuation or they'll change it slightly. And then it causes this disconnect between the one that I proposed and the one that we are using in the system. And so I now have two stories in the system that I then have to merge back together, and it's a lot of copy paste. And so now when a story doesn't have a matching pre-story, our database goes to ChatGPT, looks at the list of previous 40 stories, tries to find the one that matches up the best, and says, "Is this your story?" And then I go, "Yes, that is my story." And then it sets them up and merges them into our database. Extreme, I know, but this is each one of these things is like 5 minutes of work for me every day. And
that
so
matters.
that is productivity. I've saved myself 10 minutes a day until the robot apocalypse.
Which could be sooner than we think.
I know. Isn't that brave of me though?
Yeah.
So brave. Yeah. This is, I see these like news publications that are firing all the writers and shifting everything over to AI. I'm like, you dummies.
No.
This is going to be a nightmare.
Yeah. So you're just using it to intelligently do random shit for you, which I deeply appreciate.
Tiny little bugbears that are really hard to write software to catch these weird things that we could, but it's easier to just let, it's so simple to run it through ChatGPT that we do it. Yeah. And the other plan that I have right now is for it to look through the YouTube chat and identify questions and then put them into another database.
Yeah.
Raj Luther asks, Fraser, Pamela, have you watched Star Trek Picard season 3 yet?
No.
Yes.
I have not yet watched 2. I need to sit down and watch. Okay.
Don't bother. Didn't we talk about this last week?
We did.
Yeah, don't bother. Just watch season 3.
Okay. Yeah, my husband decided, he announced yesterday at dinner that he's set off on a journey to rewatch the entirety of The Next Generation, Deep Space Nine, and Voyager before he watches season 3.
My wife just completed that journey. And Enterprise. She watched, and the old show. She did it all and all the movies. She set upon... Wow. Yeah, she about, I guess maybe 2 years ago she began, and she went through all of the old show, all of Next Generation, all of the animated, all of Voyager, all of Enterprise, and then I had not finished Deep Space Nine, and so we watched that together, watched the whole thing together, and then we've obviously been watching Discovery and Strange New Worlds, and so she's now holds the entire corpus of Star Trek in her mind.
Yeah, he did all of that. I want to say 2013 or so, and this time he's only rewatching the more modern series.
Right.
So
yeah. The nice thing about being old is that you've forgotten the stuff that you love.
Yes.
And so you can watch it again and you're like, I don't remember any of this.
Yes.
This is the best. Who made this? What is this? What is this Doctor Who? Right? The one that we're watching right now is Bob's Burgers. And there's like 12 seasons and we love the show. and we're watching these episodes and I'm like, I don't remember none of this is triggering any part of my memory at all. Now, maybe it's just that I fell asleep, which I do.
Yeah.
Watching TV, I always fall asleep. So maybe these are the episodes I fell asleep too. But yeah, I don't remember almost any of the episodes that we're watching in seasons 1 through 3. And yeah. I think, you could probably find some show that you just love, like Doctor Who or whatever. Just watch it on repeat. Just finish or Star Trek. Start at the beginning, watch to the end, start from the beginning, the end, watch them all. Zephon saying it's like 700 hours. Yeah.
Yeah.
Right?
I have this vague cycle that I go through. Like, I tend to watch West Wing presidential election years. Like, I start with the New Hampshire primary. And then I Hate Everything, so I watch Babylon 5. And then
we rewatched Babylon 5.
Buffy, Firefly sneaks in periodically. Stargate. Yeah.
Yeah, so Stargate alone is 11 years plus Atlantis plus Universe. What was it called? What was the one?
Stargate Universe.
Yeah. So there you go. So should give that a shot if there's a thing that you like. See, like, because I crave novelty. Like, I don't like to watch things that I've seen before, and so to then kind of realize, these things that I liked are actually things that are now new to me.
Yes,
that's exciting. So, okay, what do? We are podcasters
usually.
Yeah.
All right. Do I press the record buttons?
Beth Johnson, you're so wrong. Stargate Universe is terrific. Okay. let's begin.
All right. I am pressing record button 1. I am pressing record button 2.
I only pressed one record button.
You don't record the video.
No.
All right.
Okay. Okay. Astronomy Cast, episode 680, Rogue Black Holes. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Dr. Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you doing?
I'm doing really well. I know we talk about the weather a lot on this channel. Like maybe this should just be the weather podcast, weathercast. But spring arrived finally, and it with a roar. So
yes.
We had records broken all across British Columbia because we had such a warm spring day.
I learned last week that asparagus is capable of growing 4 feet in 1 week.
I gotta plant asparagus. I love asparagus, and it's like easy to grow and it's perennial, and yeah,
it's a multi-year dedication to it.
Yes.
And this was supposed to be the first year we could harvest it, and it was just coming up above the ground at the beginning of the week, and it rained all week, and I went outside with scissors ready to harvest, and the stuff was like
you could harvest it, just cut the top, and then it'll throw more up, and then you cut those off. And
that's what I did.
Keep going. Yum. Yeah. Last week, we talked about rogue stars. This week, we're going to take things up and talk about an even more extreme event, rogue black holes. Astronomers recently discovered a supermassive black hole on an escape trajectory, leaving newly forming stars in its wake. It's a wonderful, terrible nightmare fuel. And we'll talk about it in a second, but it's time for a break. And we're back. Right, so last week, we talked about rogue stars and how they are, they adorably fly out of the galaxy on escape velocities thanks to close encounters with rogue black holes. But black holes themselves can be ejected and probably are often ejected.
Well,
so go ahead.
The thing about rogue black holes is the definition for rogue black holes incorporates so much more than rogue stars. With rogue black holes, it's any black hole that doesn't have a companion. And there's thinking that there could be 100 million rogue black holes just randomly making their way through the Milky Way, and that is awesome.
So, is just a black hole a rogue black hole?
If a black hole has a companion, a disk, something that it can feed upon so that it is not alone in this universe, it is not a rogue black hole. But a black hole by itself, minding its own business, not eating anything, or that has been ejected out of a galaxy, just to confuse things, those are rogue black holes.
Right. But does that mean a star is a rogue star? No.
No, because we can see a star.
Fine. So if we can't see it, then suddenly it's gone rogue. I guess.
Yes.
Right. All right. Okay. I think that tracks. Fine. So I guess, but it really does seem to be approaching that all black holes are rogue black holes, which is fine. I think
Sagittarius star is not rogue. It has not gone rogue. It has gone evil, but it has not gone rogue.
Sure. But Cygnus X1 has not gone rogue because it has a companion and we can see it.
Exactly.
But it is rare.
It is capable of maintaining relationships. They just aren't healthy.
Right. And as soon as it's finished destroying its companion, it has gone rogue.
Yes.
All right. Fine. I will accept your expanded terminology for what is a rogue object, which in this case is just any black hole
that doesn't have a relationship.
That isn't tied down. Yeah, exactly. Yeah, that's fine. All right, fine. So let's talk about the ones that are drifting within the galaxy.
So one of the early thoughts of what dark matter might be is just rogue black holes, random neutron stars that we couldn't see, cold white dwarfs. And so researchers set up two different long-term observational programs, Ogle and Macho. One was pointed towards the center of our Milky Way galaxy, looking at all the stars in the bulge and looking for them to brighten and fade away as something passed in front of them and gravitationally magnified their light. The other one was pointed out looking at the Large Magellanic Cloud and was looking for the exact same thing. And the thought was, if there is sufficient stellar remnants out there to be dark matter, we would within a short period of time be able to see all of them, and we did not. But over the years, they have firmly seen one 7 solar mass black hole that over a long period of time gradually passed in front of a background star and said, "Hi, I am here," with its gravity.
Right.
And that is our prototype for rogue black holes in the Milky Way.
And I mean, this is the same technique that astronomers have used to discover planets. They watch as a star moves in front of a background star, and the star flares up in a way that has like almost like a double flare, and you can see the distortions not only of the gravity of the star, but the distortions from the planet itself, and they identify the planet. The downside of that is that you don't get a second shot at it. Like once this
very true,
once in a lifetime situation lines up, you get to see it for a couple of hours and then it's gone. And so they just like stared at the entire galaxy hoping to see any of these alignments, and they saw one.
Yes. Now,
and so dark matter, though, being 90% of the matter in the universe, you'd think you'd see more.
Well, this just means that dark matter is not predominantly made of stellar remnants. It is stuff that we now define through its distribution of particles that don't like to interact, that do not interact with the electromagnetic spectrum, that may be sterile neutrinos and other similar particles. Yeah, so tiny bit of dark matter, red black holes. Most of dark matter, stuff, particulate stuff.
But they haven't ruled them out. They haven't ruled them out. They just have ruled them out at a certain sizes, right? Like from what I understand, they could either be 1,000 times the mass of the sun, or it could be the mass of an asteroid. But you can't have them in between because of these surveys that have ruled out the in-between stuff. And so the intermediate mass black holes, they're not going to line up enough, so they could still be out there, while the teeny tiny ones, they're not going to cause enough of a distortion that you're going to be able to detect it.
And this is where there is still the potential that a noticeable amount of dark matter is going to be made of these missing intermediate black holes, is going to be made up of microscopic black holes, primordial black holes that haven't evaporated away. But the more we see distant galaxies getting distorted by all of the intervening clouds of dark matter, the more evidence we have that the dominant part of dark matter, which is going to turn out to be a whole family of different things working together to break our brains.
Right. Yes.
It's going to be particles.
Yeah. And like, just to put a pin in that, like, allow me to predict the future. When people go like, it turns out dark matter was, and then you list out these 10 things, right? That it was neutrinos and gas and black holes and a kind of particle that we didn't know about before, and a different kind of particle that we didn't know before, and another different kind of particle that we didn't know before, and we didn't understand gravity at the largest distances. So yes, and all right, we're gonna talk about this some more, but it's time for another break. And we're back. All right, so we've talked about just like roaming black holes, ones that are just gently drifting through the cosmos, causing havoc in their wake. But what about ones that are on like regular stellar mass black holes? Can they get on an escape trajectory like stars?
Totally. And again, it's going to come from that same sort of multi-object interaction. And it's now starting to look like there are many systems out there that have multiple massive objects in binary systems, and all they need to do is find a third friend to send somebody off flying. We're seeing gravitational waves from black hole mergers. Now, if instead of having two that are merging, you have a third one come in, and there's lots of multi-star systems out there, that's now unstable. And so something's going to get thrown away and can escape. And it's not necessarily just going to happen with stellar mass black holes. Do we want to go there? Do we want to go to the paper?
Not which one? About the supermassive? Not yet.
Okay.
So one thing I want to talk about, like just regular, we talked about this last week. We talked about how they can have a close encounter with a supermassive black hole. They can be part of a binary star system. We talked about how one star can detonate as a supernova and the other star can be thrown out.
Yes.
But could one explode and then the other one then turns into a black hole?
So the idea that you can have a system where both stars become black holes and they fling themselves apart, they aren't going to have a sufficient difference in mass for conservation of momentum to make one of them a high velocity star. Part of the magic of the rogue stars we talked about last week is you have high mass black hole neutron star, really dense object, it's going away in one direction. And then the other lightweight thing is like, shoom! So imagine that you decide you're going to put a heavyweight ball, a cricket ball on your pool table. And you hit your cricket ball with that little white normal cue ball from pool. It's going to move a little bit and the other star is going to come flying back at you. And so that's how we get rogue high velocity stars. Now, if you just have two black holes, they're going to wander apart from each other, but they're going to still have that more normal 45 kilometers per second, but one might end up going the wrong direction. So it'll still seem to be moving at a faster velocity, but it's not as exciting because we can't see them until they decide to try and kill us, in which case we won't see them until they encounter the Oort cloud, and that's always fun.
Right. Now, you mashed together croquet, cricket, and pool there, I think?
Yes, I did.
Anyway, okay. Like I remember when we talked about the different kinds of supernovae, there's one called the pair instability supernova, which is the largest stars, where they just explode completely. So could you have, say, one star with, say, merely 20 times the mass of the sun, and then another one with 100 times the mass of the sun orbiting one another, and then the 100 mass one goes first, and now it's a pair instability supernova, so it's just gone, and now that other star is now thrown out, and then it later decides to go off as a supernova.
So I'm trying to figure out how that mass would get flown out preferentially in one direction so that the other star was flung.
Well, the one star just disappears, right?
Yeah.
The 100 solar mass star just vaporizes. No remnant left behind.
Right.
And the other one, the 20 solar mass star, is now
hanging out, going at the velocity it was going before.
But wouldn't it be? But wasn't it orbiting around the center of mass of the 100 mass star, and so now it's just careening off like regular stars, right? They're busting around each other. One now no longer exists. The other one is thrown out like a slingshot, but it's still the kind of star that's going to go supernova in the future, and so it's heading out on an escape trajectory, and then it explodes as a supernova, and now you got a black hole.
So the explosion is going to carry away the angular momentum of star 1 that goes boom. Star 2 it will have a change in its velocity, but it's not going to be huge because you don't have enough angular momentum to fling it off.
Right.
Unless you do something to the other star.
Well, one star is no longer there.
Right,
one star has disappeared.
But it's the case of you have a ball on a string, and when you let go, yes, it flies off, but it's not getting terribly huge amount of
Right.
velocity, whereas with the rogue star situation, you have one object's
Right. I
motion
see.
in
I see.
one direction and the other, that it's that extra component that you get
Right.
that gives it
Right.
the extra kick.
Got it. Yeah. 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 It's just like it's not enough angular momentum tied into the
Yeah.
interaction that when it lets go, it's a more serene escape than
Right.
right. So this idea then of a rogue black hole, because people ask me this question all the time. They're like,
Uh-huh.
"What if a rogue black hole came into the solar system?" So play that out for me. What would happen if a rogue black hole made its way through the solar system? What would happen?
So it all depends on the crossing time. So it turns out that if a black hole goes zoom through our system super, super fast, everything's going to go, wait, I'm being pulled. Oh, I'm not being pulled on anymore.
Right.
And so things get jiggled around, and that could be truly catastrophic, but it doesn't necessarily have to be. Where it really sucks is if it's coming along and it's approaching from behind and it's just going a few kilometers per second faster than us through the galaxy, and it meanders slowly through the system.
Right.
And as it meanders slowly through the system, it's able to pick up everything within the system and cause them to enter orbit around it and potentially eat everything as it goes, depending on how
Right.
much friction it creates.
Right. So, or cause three-body interactions that cause things to be kicked
Yes.
out, things
Yeah,
crash into other
exactly.
things, then those things being squished out, added to the accretion disk. So the distance, like how close does it get to the sun, and how slowly does it make this journey is the key.
Exactly. Yeah.
Right. But what I love is that we don't see any examples of it. And the solar system has been here for 4.5 billion years. And so we do not look like the kind of place that a black hole passed nearby
Well,
at any point in the last almost 5 billion years.
so the thing to think about is we cannot historically tell the difference between a large star passing near our galaxy,
Mm,
not our galaxy, our solar system, a large star passing near our solar system, and a black hole passing near our solar system. What we can say is, to the best of our understanding, there hasn't been a high mass object that passed through our solar system. But we do think that there has been some sort of gravitational disruption that has flung large amounts of comets in at various points. So we could have taken a glancing blow,
mm,
and we wouldn't have the capacity to tell the difference between a glancing blow from a black hole and a glancing
right.
blow from a star. And that's one of the most wonderfully weird parts of science, is you can have a whole variety of different things, different masses, different speeds, that have the exact same effect on our solar system. We just know
Right.
nothing destroyed us, which is good.
All right. So we are going to take another break. And when we get back, we're going to talk about supermassive rogue black holes.
Yes.
And we're back. All right, we've been waiting. Let's talk about it. Let's talk about these. So we've talked about just regular old black holes, the common variety black holes,
Yes.
but supermassive black holes can go rogue too.
Yes.
A black hole with millions or even billions of times the mass of the sun can be on a escape trajectory,
Yeah.
causing mayhem in its wake.
And what I love is we have periodically found galaxies that don't appear to have a supermassive black hole in their core, and that makes no sense by any of the dynamics we know. And we now may know why. There was a paper posted to arXiv several months ago that you discovered in the original passing.
Yeah,
And
reported it 3 months ago. Yeah, and now
it,
everybody's. Yeah, I'm not bitter. Anyway.
and this particular paper, what happened was researchers first noticed that there was this fairly dwarfish galaxy that resembled dead bugs on a windshield. And they looked at it and there was a stripe coming off of it, just this like straight line filament of light coming off of the dwarf galaxy. And we see stuff like that out there. Galaxies have jets, galaxies, all sorts of different stuff happens. But when you have a jet, it's just like a water fountain. The water starts out tightly collimated and then widens out as it moves away from the source. Well, when a galaxy has a jet, it starts out tightly collimated and then widens out as it moves away from the galaxy. But this stripe that they saw in their Hubble images turned out that it started out wide and then got tighter and tighter as it moved away. So they had some time coming up on Keck. They used that time to look at the system, and they looked at the galaxy, they looked at the system, and it turned out that the stripe, the line, was baby stars, and they had the same general age as that dwarf galaxy. And so you have a dwarf galaxy and a line of stars, same age, same redshift. What can cause that? And so they got to imaging, and they got to thinking, and they got to thinking, and they got to imaging. And what they realized is, well, when you end up with these dead bug-shaped dwarf galaxies, it's usually because mergers have taken place. And the physics of three galaxies coming together, having all three supermassive stars begin interacting, could lead to two of the stars going off in one direction and one star going off really fast in the other direction. And that one of the black holes. So you have two supermassive black holes going in one direction, one supermassive black hole going in the other direction. And that runaway singleton colliding through the intergalactic media was able to trigger star formation as it went. So basically it's going along, and as it's going, come together gas, come together gas.
Right.
And this gas coming together is forming stars, and then over time they drift apart.
Right. And we always talk about that you need some trigger to begin star formation. And we talk about it like a supernova shock wave, or maybe the gravitational effect of a nearby star. But in this case, a supermassive black hole was passing nearby and causing ripples of gas and dust to come together and cause overdensity to begin this process of star formation in its wake.
And at the furthest end, tightest pulled together part of this line, they're seeing unusual emission that's just enough different from everything else that it seems to be consistent with that supermassive black hole. And in the other direction, they see hints of what appear to be shocks in the intergalactic medium, not enough to trigger star formation, but something indicating something this way passed and left its mark. So now we have dead bug-shaped galaxy with no supermassive black hole, and three rogue supermassive black holes, two flying together, one by itself, passing between the galaxies. And this raises the interesting idea that at any moment, a supermassive black hole could emerge from the darkness and begin interacting with the space around our galaxy or any other galaxy. And it might not be easy to see, but it would sure be cool if it happened.
Would you need that three-body interaction? I mean, is there any way you can get a two-body interaction with a supermassive black hole and a less massive black hole?
In that situation, they're just going to merge.
Right.
You have to have that unstable third system to fling something away.
But when you think about even the history of our local group, we've got the supermassive black hole at the heart of the Milky Way, the one in Andromeda. There's probably supermassive black holes in several of the dwarf galaxies around us.
Yeah.
Triangulum doesn't have one, which is back to that, who knows where it
bad happened here.
Right.
Yes.
And so you can imagine two dwarf galaxies merging together. Their supermassive black holes haven't merged yet. That combination reaches the center of the Milky Way and Andromeda, and
then it can get flung. Yes.
and then one gets thrown out. Yeah.
Yeah.
And in those big galaxy clusters, the ones seen early on in the universe, you're seeing like just so much material coming together in these gigantic galaxy clusters. I mean, there aren't many of them out there. There are dozens maybe that astronomers can see of the ones that are truly into the billion stellar mass black hole range, right? And those are just, they're ludicrous. The forces involved and the kind of mayhem that's going on in those places.
The thing that this gets me thinking about is, for decades, it seems like every other American Astronomical Society meeting, they're announcing a new shredded dwarf galaxy star stream falling into the Milky Way has been discovered. And there is a chance that the majority of those stellar streams were once upon a time a dwarf galaxy associated with a intermediate mass black hole, a baby supermassive black hole. And so now those masses are somewhere.
Yeah, out there somewhere.
Yeah.
Could be here, could be there. Who knows? All right. Well, on that note, thank you, Pamela.
Thank you, Fraser. And thank you so much to our audience out there. You are making this show possible by supporting us through patreon.com/astronomycast. And if you aren't a supporter and you want ad-free versions of our show, consider joining our Patreon. This week, I would like to thank Kim Barron, Paul Esposito, Bob Zatsky, Arthur Latz Hall, Ron Thorson, Corinne Dimptruck, Philip Walker, Hal McKinney, Bruno Letts, Jimmy Bergeron, Jean-Baptiste Le Martinet, Time Lord Iro, Daniel Donaldson, Frank Stewart, Will Hamilton, Christian Golding, Michael Prochoda, Galactic President this one doesn't even fit on my screen. Galactic President Scooper Star McScoopsalot. I love that name.
It's amazing.
And John Thays. Thank you all so much for letting us pay the folks that make us look good.
Thanks, everyone. We'll see you next week.
Bye-bye. And then they saved.
And then our heroes saved.
All right.
It's 8-0.
Yes. Let's see. So we have the question coming in. We have someone whose username is MurderCom over on Twitch. Hello, MurderCom. And they want to be the first one to enter a black hole. So I feel like their username is relevant. Real Fake Admin asks, would that mean the majority of black holes are rogue? I don't know. Because I don't know the initial mass function for stars and binary systems.
So we know that the vast majority of the majority of massive stars are in multi-star relationships.
Okay.
The majority of stars are singletons when you include the red dwarfs. But but in the brighter stars like the sun and brighter, they're in multi-star relationships.
Okay.
And because these live fast and die young, the vast majority of the stars that have ever lived that have been heavy are dead.
Yeah.
And they were once in multi-star groups. Therefore, yes, I think, as I do my Fermi estimate, most stellar mass black holes are of the rogue variety and are not in a relationship anymore.
Well, so are they majority binary systems or tertiary or higher systems?
I don't know that part.
Because if majority binary, you can imagine them with lots of vampiric back and forth mass sharing, both ending up as black holes. But then they would eventually merge together into a singleton. So yes, you're right. I agree. It just took me a hot second to get there.
Hit us with your questions. Otherwise, you get a rant. This works. This is your
You
chance
had
to
a
have your.
good one at the beginning of this episode when we were talking.
Yeah, 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 yeah. I don't know what the solution to that one is. Which is that, and like I hate, I don't want to like sort of rest on my laurels here, but we're so good at finding stories at Universe Today now.
Yeah.
That we report on them months before other people do, and the lag is so big, and nobody kind of like when someone finds like reports something really interesting and everybody just says so and so over at such and such is reporting this, like nobody else
Yeah.
knew the story, and so you break the story. We're not that popular yet, so we're not like Universe Today is reporting that astronomers have found a rogue supermassive black hole. So we're not at that point. We're merely at the everybody ignores it until the press release comes out. And so we're in this really uncomfortable place where we report a story and then months ago, and then the press release finally comes out and everybody else reports the story, and then I've got to make a call. Like, what do we do?
Yeah.
This is old news, so we can't report the story. And then I get people saying like, why didn't you guys report this? And I'm like, we did
Long, long
3 months
ago in a
ago.
universe far, far away.
Yeah, if you following Universe Today, like a good reader, you would have known that we did. And we crushed everybody. We scooped the world. So I don't know what the solution is.
So
We either just pretend that we didn't and just rewrite the story.
I'm telling you, you just update the story with a link to the new paper so that
Yeah.
it pops to the top again.
Yeah, I don't know. I don't know. Anyway, that's my if it's a rant,
Criticism of the universe.
that is my criticism of the universe. The better I get at doing my job, the more I get punished.
No good deed goes unpunished.
Yeah.
This is a truth.
Yeah. So Zafan saying, correction to the previous show, hypervelocity are 0.1 to 0.3% of the speed of light, not 10 to 30%. So you talked about this last week. And so the 10 to 30% is the theoretical limit estimate based on the Penrose process, based on the speed that material will be ejected out of a black hole in the perfect scenarios, and not what has been observed.
Yes.
And so the ones that have been observed, I've done a bunch of follow-on research on this. And so the ones that have been observed and have been in the sort of 1,000 to 2,000 kilometers per second range, which is on galactic escape velocity. But the numbers that you were quoting were the idealized theoretical limits, and none have been observed. So apologies, Zapat. I know you're trying to reach us with that last week, and I sort of had to dig into that to kind of find out what was going on, and that's what.
So we were both right.
Yeah. Just like, but I think we get the impression that those have been observed.
Yeah, that's true.
But the velocity material that is ejected out of a black hole can be theoretically at that limit, but you wouldn't have a proper star coming out the other side of it. You would have a stream of material. Miguel Angel Romero says, "Oh, I have a question. Who's the dude next to Dr. Pamela in the Astronomy Cast video thumbnails?"
That's this dude. This dude.
Me?
Yeah.
Is that me? Is that not me? Yeah.
Yeah.
Well,
it's just
an
older
Miguel
picture.
Angel Romero knows an older picture of me. Oh, okay,
Yeah.
I see.
It's an older picture of both of us. We haven't updated in a long time.
There we go. Raj Luthra asks, traveling through space, how fast can a black hole move at? So same thing, and in theory, right? Like a black hole isn't going to tear apart.
Right.
So you could theoretically hit, and I don't know what the speed of that supermassive black hole was, but it was in the thousands of kilometers per second. Ryan Schmitz asks, what would be the first signs of a black hole entering the solar system slowly look like to our telescopes? That's a great question. What would we see?
It's flickering high energy particles as it hits the Oort cloud and consumes things, and they let off bursts of X-ray and gamma ray light.
So we would see this gamma ray spot in the sky.
Yeah. Fireworks, basically.
Because that's the method that people have proposed. Like, if Planet 9 is a primordial black hole, then in theory, you would catch the occasional sputter of gamma radiation as it consumed little things out. But a large black hole, you would see more of that.
Yes.
Wow.
Yeah.
Yeah. That you would see the Penrose process in action. You would see the high energy radiation and particles coming off of the black hole as it's consuming. That would be the first thing. And we do have all sky gamma ray surveys that have been done.
Yeah. And we haven't, there is nothing currently wending its way through the Oort cloud.
Right. Yes. Ben Cagle asks, do you think our human brains have a limit to understanding? When will we know when we confront incomprehensible knowledge?
Pass? I have no idea.
Well, like, how do you... So I actually had a chance to interview somebody years ago, and I'm not going to say his name because he has done some bad things. But I asked him sort of a version of that question, and he said that there are obviously things that we don't know. There are things that we can't know, or things that we won't know, things that we won't learn. And then there are also things that we literally cannot know, that they're like the Heisenberg uncertainty principle, that there are knowledge that you cannot know, even in an idealized state.
Yep.
That they will always be forever beyond our limit. And I talked to Paul Sutter a couple of years ago about this, and there's this idea of, and you're going to have to help me along here. What's the term? Someone's got a term about this, but the gist is like there's a limit to how much information we can get out of the cosmic microwave background radiation.
Yeah.
And Planck did that. So we actually can't get a more accurate measurement of the cosmic microwave background beyond what the Planck telescope did. What's the name of that? Like I said, someone's got a blog. It's like, it's not back reaction. That's Sabine Hassenfelder. But there's like a limit to the amount of information that you can get from the CMB. So you couldn't launch a super Planck and get a better measurement of the CMB. We've reached the measurable limit, and that there will be measurable limits for everything.
But we still can get better like polarization data and stuff like that out of it.
Correct. Yeah, and that's what he said. And he said like we can't get we can no longer get better temperature map data out of the CMB, but we can still get polarization data. We can still see ripples of gravitational waves. Like there's other stuff that we can see. I
can't quickly Google it either.
Yeah, no, I forget the term. Hopefully someone will mention in the chat, but it's like, I hate this. Okay, all right. So anyway, so there will be information that we can't answer, and as our telescopes get better, we will study all of those things to the best of our ability. But when you think about, like, I could put a camera outside my house and discover an almost infinite amount of stuff in the forest, right? That there is an entire universe out there.
I last week, 2 weeks ago, was reading a piece on vents that fields of hydrothermal vents that have been discovered by a brand new research vessel. And they were talking about how this brand new vessel has the capacity to map the seafloor with 1 meter resolution. And it was one of those moments of, I firmly believe that there is more unknown about the universe as a whole than there is about under the ocean.
Mm-hmm,
But
mm-hmm.
realizing we have higher quality maps of the surface of the moon than the floor of the ocean was sort of like, huh, okay, not a fan. Can we fix this, please? But it's a lot easier to fix our understanding of the moon because we can just set things in orbit
Mm-hmm.
than like once you get to the bottom of the ocean, you have to just keep expending energy to keep yourself moving along. Orbits
Yep.
make things so much easier.
Yeah. Yeah. So Lionel's saying is Ethan Siegel. So no, it wasn't Starts with a Bang. It wasn't Ethan Siegel.
Yeah.
Cosmology blogs. Now I'm gonna just obsess. Please continue.
Was it
Okay.
something that Sean did?
What's Sean's? What's his?
Cosmic?
No.
No.
Nope. Cosmology terms. It's going to be in cosmology, a glossary of cosmology terms.
And the rabbit hole has been found.
Come on, come on, come on. Well, you grab another question here.
Okay.
No, it's not anisotropy. Roger Luther asks, is there an upper limit to how much a black hole can increase its size?
Sort of. So the sort of comes about because if you have a supermassive black hole in the core of a galaxy, as material streams into it, conservation of angular momentum will cause the material to begin orbiting in a disk that gets denser and denser and denser and starts undergoing thermonuclear reactions within the disk. And that light exerts so much pressure that it stops new material from falling in. And you essentially hit this point where supermassive black holes are self-limiting in how large they can get, but you can imagine multiple episodes. So, yes and no. There are upper boundaries in what we expect, but not a thou shalt not ever see a galaxy bigger than that, or a supermassive black hole bigger than this.
But if you, in idealized circumstances, just kept feeding black holes to other black holes, there'd be no
Yeah.
limit.
Yeah.
Yeah. The thing that's kind of cool is, have you heard this that if you take all of the matter, energy, dark matter in the observable universe and you turn it into the equivalent of a black hole, the event horizon of that black hole is the same size as the observable universe.
I have heard that. People try to use that to like explain all sorts of stuff. And my brain just shuts down and says no.
Yeah, it's purely a coincidence. It's like the same kind of coincidence. Like, isn't it weird that the moon is the same size as the sun in the sky? And there's nothing else to it.
So we have a question over on Twitch. Do we know Sergio Sacani? He appears to be a Spanish language YouTuber.
No.
Okay. He does spacey stuff.
Cool. Yeah, I don't know. Arjun asks, if the standard model stands unchallenged, what would we have to do to try to explain dark matter?
So the standard model isn't inconsistent with dark matter. The standard model, there's nothing about the standard model that says, I am complete. So we regularly find like 5 quark particles, 4 quark particles that weren't initially predicted. What hasn't happened is the folks that keep saying, well, we want supersymmetry, we want this specific other version of particle physics to exist. None of them have been proven true, but the standard model has space to allow additional particles to be found.
I mean, isn't like the standard model include dark matter, but with a question mark in it that for what dark matter is?
So the standard model, no, not really. It leaves space for it, but it doesn't require it.
Okay.
It can't predict it, is what I'm getting at.
So Arjuna also asks, how far could a supermassive black hole get from its home galaxy? Could it make it to another system?
Oh,
Triangulum
yeah.
seems to be missing its supermassive black hole.
Yeah,
And
totally.
how?
Just the fullness of time.
Yeah. I think that's it.
All right.
So, did anything else show up on Twitch?
Nope. Just folks saying hello. Hello, Argilept. I don't know how to say your name. RG. I'll go with RG. Hello.
Wait, is it variant cosmic variance?
Yes. That's Sean.
Yeah, but the term cosmic variance is the statistical uncertainty inherent in the observations of the universe at extreme distances. That's
Oh,
it.
that's
That's the
clever.
one. Yeah.
Okay.
It has so cosmic variance. Yeah, it is. It's Sean's blog. But so the most widespread use to which this article reflects the fact that measurements are affected by cosmic large-scale structure, and so a measurement of any region of the sky viewed from Earth may differ from the measurement of a different region of sky, also viewed from Earth, by an amount that may be much greater than the sample variance. In other words, if you try to view one chunk of the sky from Earth, and then you try to view another chunk of the sky from Earth, the variations are bigger than what you can measure.
Okay.
And so it is impossible to learn anything more.
All right. All right. I say we escape before we break your brain anymore.
Now I can sleep. And then who knew? Sean Carroll had the answer all along.
Always. Always.
Yeah. All right, cool. Well, so what's happening for me? I got my question show coming up. We just released a really great interview all about dust on the moon and dust on Mars and how awful it is.
It really is.
It's so awful.
True.
Like every time I think I have my head wrapped around how awful lunar dust is going to be.
No, it's worse.
It's worse. Yeah.
Yeah.
Both in the damage that it does
Yeah.
to every single thing that's going to be operating on the moon, including the people. And then how difficult it's going to be to remove it.
Yeah.
Like, I don't even think it's possible. Like the only way to live on the moon is if you never go outside. You never let this dust get into your machines, your equipment, all that.
I think the best hope we have is the spacesuits that you slide into, if they can figure out how to like double do the wall so that any dust that's on the outer part that slides away so you can get in and out has no hope of getting into your spacecraft.
But can you imagine any part of that spacesuit that may need to turn or twist and require some kind of like
maintenance?
Right? Like anything needs to turn, your hand,
Oh, yeah.
your fingers, right?
Yeah.
The dust is going to get inside and then wear it away.
Oh, yeah. It's
then
going
you're
to
gonna have to
destroy everything.
Yeah, you have to fix it. So you have to bring it inside your space. Like, yeah, this is a nightmare. It is a nightmare. Like,
Yes.
people do not understand the level to which this is going to be a nightmare. It's a nightmare. Yeah.
Yes.
Yeah, and there's no solution. There are ideas. The best solution. Have we done the perils of space? I'm sure we have. But anyway, the best solution is spraying liquid nitrogen at you.
I did not know that.
Yeah, that is the most non-invasive solution that people have been able to come up with, is you hose yourself down with liquid nitrogen.
Oh, God.
Yeah, which, has its downsides. So, yeah, anyway. Okay, on that note, on the nightmare that is space, the space is trying to kill us at every level. Every level.
Every level.
Thank you, everyone, for watching us today. Thank you for all the moderators. Thanks in advance to the producers who will have to edit this stream of consciousness. And thank you, Pamela, for bringing the brain.
Thank you, Fraser.